Let's roll.
Okay, ready?
Yeah.
Is it going?
Go ahead.
Okay. Hello, I'm Andrew Kruczkiewicz of the International Research Institute for Climate Society at Columbia University, and we're here in beautiful San Francisco in the Moscone Center, and we're at AGU, American Geophysical Union. It's about 25,000 people here. It's awesome. And I'll be presenting a talk here. So basically what I'll be talking about is the connection between environmental variables and leishmaniasis, more specifically how to use remote sensing to understand the relationship between environment and leishmaniasis, and also maybe talk about ways where we could explore how to forecast the distribution of the disease. So just very quickly, leishmaniasis is a vector-borne disease, and this is very important because being transmitted through a vector, in this case a very tiny sandfly, 2.8 millimeters, being a small insect, they're very sensitive to changes in the environment. So for example, changes in temperature, changes in rainfall, also changes in inundation. The vector, being a sandfly, actually breeds in the soils. So we're trying to understand if inundation of these soils changes the distribution or the risk of distribution of leishmaniasis. So yeah, so why remote sensing? That's a good question as well. Usually in the United States, places like the United States and the UK and Australia, we have a fairly decent network of weather stations. So with this network, we're able to get a better idea of the distribution of different temperature, different environmental variables like temperature and rainfall. But in South Sudan, we don't have that luxury, and that's where this project focuses, East Africa and specifically South Sudan. So what we must do is use remote sensing or satellite data to get a more widespread view of the distribution of temperature, rainfall, inundation, and then possibly tie that back into leishmaniasis distribution in order to think about, well, are there changes in the environment where the distribution of the disease is affected, and possibly can we use those changes, or can we forecast those weather changes and in turn forecast changes in the disease? So thank you. Come to my talk, please. That's it from San Francisco.